A digital twin is a virtual representation of a building or installation that can be used for monitoring and control. Data from sensors can be displayed with charts and gauges. Devices can be controlled with switches or sliders. But what if we need to display more complex custom graphic displays, such as a compass, complex panel, or a process diagram? In this video, we show you how to create custom 2D interfaces using visual programming. When creating a new drawing, you can drag 2D components, such as lines and circles, from a library into a workspace. You can add repetition statements, for example, to create minute markers on the face of a clock. Add conditional statements to change the thickness of the markers for every 5 minutes. Drawings can be made dynamic by adding parameters, such as for hours and minutes. These parameters can then be used to show the hands of the clock. The clock is redrawn when you change a parameter. Now that we have defined the clock, we can display it in a standard web browser, just like an image. You enter the name of the drawing and an optional list of arguments. You can also embed the drawings in a web page of a digital dashboard. Drawings can be used as parts in other drawings. This example shows a compass with a parameter heading. The drawing is stored in a library called Air. You can create a new drawing and include the compass by selecting the library and selecting a part. The block will automatically add fields to specify the parameters, in this case the heading. You can duplicate the part and add a move block to position the second compass. This drawing shows a primary flight display used in airplanes. The drawing includes several other parts, such as a speed tape and artificial horizon. The display can be shown in a web browser with different parameters. You can automatically update the display by streaming data from an MQTT server. For example, you can send a message to a free MQTT host and enter the ID of the aircraft in the topic. The message is a comma-separated list of parameters that define the state of the aircraft. You can set up a connector by specifying the MQTT host and the topic for receiving messages. When a new message has arrived, the parameters in the message are parsed by the JavaScript split function. Here we see two displays, each for a separate airplane. You can use a command line tool to send a message to the then MQTT host. When a message is received, the connector is run to parse the data, and the display is updated. Drawings can also be used to control data and devices. This example shows a seat selector. The selected seats are stored in a parameter called occupied. You can add interactivity to the drawing by adding an on-click block. If the user clicks on an element, the current seat label is added to the value of the parameter. You can use a similar block to remove the selected seat if it is occupied. This example shows a process diagram with a pump and 3 valves. The state is stored as an object with fields for the pump and the valves. The color of the lines depend on whether the pump and valves are on or off. You can now add an on-click event for the pump and the valves, where the state is toggled between on and off when clicked upon. You can set up a bi-directional connection with an MQTT server. The message includes the state of the pump and valves. When a message is received, the connector parses the message and updates the diagram. To view the outbound MQTT messages, you can subscribe to the MQTT host. When you click in the drawing, a message with the new state is sent to all subscribers. This can be used to control a real-world pump and valves in an irrigation system.